Fifth graders, today is Tuesday, January 14th, and we are doing Module 3, Lesson 9. Okay. Today we're going to take a closer look at adding fractions, and we didn't forget about the number lines from yesterday. Number lines will come back to use today, but we're going to really focus on how we can use different versions of fractions, how we can make equivalent fractions in order to make it easier to add. Okay? LCM stands for least common multiple. It's easy to understand what this phrase, least common multiple, means if we take a look at each word. What does the word least mean? It means smallest. What does common mean? It means like what you have, none are the same. Good. Now, this is the tricky part. What's a multiple? It's like math facts. It's like counting, skip counting. 2, 4, 6, 8. A multiple is not a factor. It's tricky because we get those two words mixed up a lot. Is a multiple equal to and greater than, or equal to and less than a number? Equal to and greater than. Good. A multiple is any multiple of that number. I don't know how else to say it, right? Okay. So the LCM, least common multiple, really could be also called the SSM, the smallest same multiple. Okay? So let me give you an example. If I want to find the least common multiple of two numbers, 5 and 3, here's one way you could find it. You could list all the multiples of one number. Let's skip count by 5. Ready? 5, 10, 15, 20. Let's stop there. Okay? Do you see how we listed out all the multiples of that number? I want you to get in the practice of doing this, so Jonah, write it down. I want you to write down also which number you're skip counting by. Okay? Our second number is 3, so write down that we're going to list all the multiples of 3. Ready? Go. 3, 6, 9, 12, 15. We can stop right there because we can see that we have something in common. 15 is a common multiple of 3 and 5. It is also the least common multiple. Is it the only common multiple? No. What's another common multiple between 3 and 5? What about 30? Right? But 15 is the LCM. It's the least, smallest one. Does that make sense? Good. Try to see if you can find the least common multiple of 5 and 11 now. Go. When we skip count and list out all the multiples of 5 and 11, we can see that 55 is the first common one. Because we're listing the numbers from smallest to biggest, the first one is always going to be the least, right? So 55 is the LCM, or least common multiple, or the same smallest multiple, of 11 and 5. Now, can we only find the LCM if we have two numbers? No, we can also find it if we have more than two numbers. So let's see if we can find the least common multiple of three numbers now. 5, 4, and 10. So, after listing the multiples, we can see that the least common multiple of 5, 4, and 10 is 20. Good. We know that when we have to add or subtract fractions, we need to make like units. We don't have like units right now, right? We have halves and we have thirds. But we can use the concept of the least common denominator. If I have a common denominator, does that mean I have common units? Right? So the least common denominator could also be called the least common units, right? But it's called the least common denominator in order to make like units. So what I can do is I can take my two units, or two denominators, which in this case is a 2 and a 3, and I can find out what the least common multiple of those two numbers would be, because the least common multiple would therefore be the least common denominator. Does that make sense? So let's see. Let's skip count by 2 until we have something that's also divisible by 3. Oh, look, 6. Good. And then for 3, we could say 3, 6. So what is my least common multiple between 2 and 3?
6.
What's my least common denominator in this fraction going to be then? 6. That means I have to rewrite the fractions to, I have to rewrite the fraction so that they have 6. So instead of 1/2, I need to make it some number of 6. How can I use multiplication? Well, can I multiply 1/2 by any number without changing its value?
Yeah.
What number could I multiply 1/2 by without changing its value? Everyone?
1.
1. but there needs to be some version of 1, right? So I have to do, and I think to myself, okay, well, if I have to go from halves to sixths, 2 times 1 will equal 6. Everyone? 3. But I can't multiply by 3. I have to multiply by 3 over 3. So therefore, using multiplication, in the top, in the numerators, I have 1 times 3 equals 3. And in the numerator, I have 2 times 3 equals 6. So therefore, 1/2 is equivalent to 3/6. My second fraction was 2/3. I know that I can also make it equivalent to some number of sixths because it's what we have, right? So therefore, I have 2/3 because I know that 6 is going to be my least common denominator. So I think to myself, in my denominator, 3 times something will equal 6. 3 times 2 equals 6. So what version of 1 should we then multiply by? 2 over 2. So then we can multiply in the numerators. 2 times 2 is? 3 times 2 is?
6.
So therefore, 2/3 is equivalent to 4/6. So now I can rewrite my addition problem. Instead of 1/2, I can write 3/6. Instead of 2/3, I can write 4/6. So now I can add. I have like units. 3/6 plus 4/6 is?
7/6.
Which is? 1 and 1/6. Good. Now, prove to yourself that this is true by drawing rectangular fraction models. Using our rectangular fraction models, could we see that 1/2 is equivalent to 3/6 and that 2/3 is equivalent to 4/6? So really, the math we just did is the mathematical representation of all the rectangular fraction model work we've been doing. Does that make sense? Whoa, yeah. Cool. So when we were listing out the multiples for 9 and for 6, we could see that there are multiple common multiples. 36 is common and 54 is common. So which one is the least common multiple?
18.
Oh, and also 18, thank you. So which one is the least common multiple? 18. So what does this tell us? Do we always multiply to find the least common denominator? No. But let me tell you something though. As long as the units are the same, the math will work. We could find equivalent fractions with 36ths or with 54ths, or we could do it with 18ths. Either one should get you the right answer. However, what do we know about working with larger numbers? It's easier to make mistakes. Okay? It's easier for us to think about and work with smaller numbers. That's why it's the best to work with the least common multiple or least common denominator because that is smaller. However, the math should work out if you use 36ths or 54ths as well. You'll just have to simplify the fraction more, and that's just more chances to make silly mistakes. Okay?